Hi everyone, welcome back. So in this second video this week, we're going to take what we did in the previous example where we built our animation sequence for our player, and we're going to start to lay the foundation for our game. What that means is we're going to start to write our basic game objects. So rather than just leave, right now we kind of have everything we need to represent the player, right? We have the animation over here. We're using the mouse position to control the player. So technically, like all the code is in there already. But what we're going to do is do a little bit more of like organizing our code by specifically creating an object to represent the player. The reason we're going to do this is twofold. First is because the zombie object is going to borrow a lot of concepts from the player object. They're very similar in the game. The only real difference between them is the player is controlled by me, the player, and the zombie moves by itself, right? Everything else, they kind of share similar functionality. So creating an object or a template for the player is going to make our lives easier when it comes time to developing the zombie. We're going to have a starting point, right, to build a template for the zombie from the player. So that's reason number one. The other reason where it pays off to think a little bit about structuring your code in that way, or whether you choose to only use functions or you don't have to use classes, but we're doing it in this example. It's going to allow us to now build on top of higher levels of abstraction, right? And what I mean by this is instead of just having this kind of somewhat abstract code inside draw here that has to do with drawing and animating and moving the player, we're going to replace this with an object, and we're going to attach some concepts to it by giving that object functionality. Okay? And so once we create a game object for our player and for our zombies, programming our game mechanics is going to become a lot easier, because instead of operating at the level of these individual variables, we're going to now have different objects that interact together in our game. Okay? So what we're trying to do here is just kind of structure our code, scaffold things so that as we build complexity, things remain manageable. There's so many different ways you can decide to structure your code. In fact, this is a really deep topic. This is not the focus at all of this series of tutorial. Is we're not going deep into software engineering and best practices and so forth. We're just kind of get a basic idea of how we could improve organizing our program here, and what kinds of things we might want to use to structure a simple project like this little game. Okay, so uh, it's definitely not going to be necessarily always best practices, but it's good enough. And when it comes to creative coding in general, I think good enough is often exactly what you need, right? We're going to be building small projects, and you just want to make it work. Okay, so whatever works for you is good enough. All right, so let's talk about turning our player into an object. So in order to do that, we're going to write what we call a class. And we saw this in last week's videos. So a class is basically a template, and we're going to call this template player, because this is going to represent our player object. A class is basically a blueprint or a template for an object in our program. And objects are going to be a combination of variables, right, or data. And also, along with these variables, we're going to be able to package some code, some functionality, things that our object can do in the program. And the first thing we have to do when we write a class is we write what's called a constructor. Note that the functions we define inside classes, right, don't have the function keyword in front of them. That's how JavaScript can tell them apart. And so we don't put the function keyword, and we just put the name constructor. This is kind of the setup for the class, right? This is the code that's going to run when we create an object from the template. Now, it's a little bit strange to create a template for something we're going to have one of. In this case, we just have one player. I mean, there might be a future version of that game where we might have a two-player mode, and having a player class will be handy. But even though we're just going to have one player, there's still a benefit, again, to creating that structure, because we're going to have a player object, and then eventually we'll have a zombie object, and those two things will interact with each other. So kind of packaging our code in that way is going to help us with the more advanced game logic and the rest of the structure of the game. So the constructor is what happens when we define a player object, and this is where we're going to put the variables that belong to our player class. Okay, we could have parameters to the constructor if we wanted to, but in this case we just have the one player, so we're not going to really need parameters. Okay. So what are things that define our player? Well, we have a few things, right? We are going to have a series of animation images, an animation index. This is the current place we are in the animation for the player. We have our flip variable. That's the number of that's representing which way the player is facing, right? And we also have position. Now, in this example, we're just using mouse X and mouse Y to set the position of the player. However, in the object version, we're going to take the time and create variables to represent the player's position. Okay. So instead of just baking and embedding mouse X, mouse Y into all of my player code, we're going to separate these two ideas. Okay. We're going to say we have this object called a player, and that object will have a coordinate inside of it. It will have an X and a Y value. Okay. And it may turn out, as we're going to do in this example, that when we move the player, we're going to make this coordinate equal to the mouse position. But we may not want to totally commit to that idea. Maybe down the road, when we play test our game a little bit, we realize actually it'd be nice if the player could move using the keyboard keys instead. Okay, so by not necessarily by sort of separating the concept of the position of the player from the mouse cursor, having separate variables for that, that's going to open the door to these types of future upgrades. Okay? So long story short, we're going to say the player object will have an X and a Y attribute inside of it. And to begin with, we'll just set them to 0 because we know we're going to update them as the program runs. Okay? We're also going to have an animation images variable. Okay? Now here we have a choice to make. Okay, we could decide to load and create the animation images that we have up here, right? We could decide to kind of define this as an array here, and then in the constructor we could have code that would load the images. If we do it that way, there's two downsides. One is we can't take advantage of preload, okay? And also for the player, it won't be that big of a deal because we only gotta have one player object. But kind of thinking ahead to our zombie template, if we put the animation image loading and creation array creation code in the constructor, it means that every time we create an object from that template, it will create its own copies of the animation frames. Okay, so for the player, it's not a big deal, but for the zombies, that's gonna kind of suck because we're gonna have maybe hundreds of zombies, and there's no reason they each need to have their own version, right, of the images. They can all basically share the same array when it comes to drawing. As long as they have a different index variable into that array, we'll be fine. Okay. So what that means is that we are going to assign this animation images here. We're going to just assign it our animation images array we've created up here. Now, to keep things from getting too confusing here, we're going to rename this to mPlayer frames. Okay, we're going to rename this array to mPlayer frames over here. These variables are going to move eventually into our class, so we're going to leave them for now. Of course, this is going to break our code temporarily, but we'll get back to that in a second. So we'll say mPlayer frames, that's going to be equal to animation images, is going to be equal to mPlayer frames. So what we're doing here is just referencing a global variable we created up here. And then in preload, we're going to fill that array with images. And when we create a player object, it's going to simply say, use that array as your animation images. Okay? Down the road, we're going to have, in fact, two different possibilities for the player. So we'll have some code that will be able to decide, which animation sequence we're going to want to use here. But that's for the finishing touches in the last video. Okay. So we said we need the animation images array. We're going to need an animation index. And let's start at 0. We want to start at the first frame. And we'll have a flip variable, and we'll just assume 1. Of course, that's going to change as the player moves. Okay. So the constructor here is going to create all of these variables into our player object. Okay. Now our code's not going to be able to run here, so I'm going to comment. In fact, I'm just going to delete this. I'm going to comment this out, okay? Just so I can hit play again. I needed num frames here. I deleted too much. Let's put that back. Okay. All right, just so that I can hit play again. And now that we've starting to build our player class, what we're going to do is we're going to create a player object so that as we add functionality, we'll be able to test it. So we need to create a player variable so that we can try our class out. And we're going to call this variable player lowercase. Okay, so again, pay attention to the case here. Player lowercase is going to be the name of my variable. Yeah, I could call this anything. I could call it dude, like I'm going to just call it player. And player uppercase is the name of my template, right? As far as P5 is concerned, these are different labels, right? They represent the same word to us in English, but they have different spelling. Therefore, they're completely different things. And typically we use uppercase names for class definitions. That's just out of kind of convention amongst programmers. And then we use lowercase when we refer to instances, actual variables from that class. So in setup, we're going to create our player object by saying player equals new player. So this syntax calls the player class constructor, right? And it's going to run this little bit of code right there. This is going to create all these variables onto the player object using the this keyword. And then the resulting object we put into our player variable. Okay. All right. So now, we have player.x, right? Player.y, player.flip, right? All of these are attributes of the player object. Okay. So we've created a class, we've created a constructor. Now it's time to add some functionality to our class. And we're going to do this by adding what's called methods, aka functions inside a class. Okay. So methods is just a fancy name to differentiate between regular functions that just kind of live in the program, in the ether, and functions that belong inside a template. They just have a special name called methods. So what does the player do in our program? Well, it does a few things. I mean, we have here, we have some motion code, and in this case, the motion is going to be, let's define a motion, move, right? So this is what's going to determine how our player moves. This might be as simple as just make your position equal to the mouse cursor. Okay, this is our, oops, didn't mean to collapse that. We could have a version of this code where we might want to experiment with the keyboard, like I said, right? Or maybe connecting it to a joystick or whatever. So this is the code that's going to be responsible for moving the player, updating the player position. And in draw, if we want this code to run, we're going to say player.move. Okay. In addition to that, we might want to also include in the motion, right, updating the flip variable, right? So we have this from before. Let's bring that also into move. So I'm going to uncomment these lines here. Now we just have to do a little update, right? And so actually we're going to leave it as is because we're using the mouse coordinates. So we're going to leave that as is. The small update we're going to do here is now that we're changing flip, right? Remember before we were just changing a global variable called flip. Now we're going to change this dot flip because we're writing a template, right? So we're going to say this dot flip, this dot flip. Okay. So whenever we call move, this is going to tell our player object to update itself. So it's going to update both its position and its direction. Okay. Another function we want to put in is draw, right? What needs to happen when our player needs to draw itself on the screen? I'm going to call it over here. And this is our drawing code, right, from before. So we're going to bring that into draw. Okay. I'm going to uncomment. And now we're also going to do a few updates because before we just had some code in draw that showed the player. Now we're inside this template. So instead of mouse X, mouse Y, we're going to refer to this dot X, this dot Y. Okay. And instead of flip, we're going to be referring to this dot flip, because remember when we write these functions, we're kind of writing them from the perspective of the object itself. And when we write this dot, we kind of basically what we're saying is we're saying mine, right? So my x, my y, my flip variable. And that means that is because we might have multiple instances of a particular class. So while they all share the same code, they refer to their own variables using this keyword. Okay? So we're going to scale like this. And same thing here. We're going to use my animation images, my index, okay, to draw myself. And of course, we're going to also think about, down the road, we're going to draw other things in this program. And if we translate and scale, this is going to mess up the origin. It's going to move the origin to where the player is. It's going to flip the entire canvas. So probably the other things we want to draw are not going to want to be translated and scaled. So we're going to put a push and a pop at the beginning of this draw method. Just kind of acknowledging in the future, if we want to draw other things, we don't want them to be affected by these transformations. So now we should have our character, right, following the mouse. The only thing missing is the animation. Okay? So maybe we'll create another method here. Let's call it animate. Okay? And we'll say player dot animate in draw so that we actually run the code we're about to write. And we have these two lines left over. This is how we did our animation, right? So we're going to bring that into our template. I'm going to say animate uncomment, put that in here. And now we, again, have to do these updates. We're going to say my animation index, right? This is important because these are no longer global variables. These are variables internal to our object. And now we have this little bit of code that's going to animate our player. Okay. Now I decided somewhat arbitrarily to divide things up in that way between move, animate, move, draw, and animate. Okay, these are just decisions I made. One thing I also like to do here is just like we use these lines up there to separate, we could use a different symbol here. Just I don't know, put some stars, whatever. Again, just to kind of make it a little bit easier to see the demarcations. I decided somewhat arbitrarily to break down the functionality of my player into these three different methods. Okay, I could have packaged it all into one method that just says do your thing. Okay, that would work too. But the problem is, maybe there are times where we might want to move and draw the player but not animate it. For example, when we're game over, right, we kind of do a freeze frame on the current state of the game. So in that case, maybe we don't move or animate the player, but we simply draw it, right? So now we have a little bit of flexibility, right? So we've built in some options so that as we develop the rest of our game, we can, we'll be able to decide when we want these things to run based on kind of the other things that are going to happen in our game. Okay. So out of, habit, because the more you write some programs, at some point you start to find ways that work for you of how you want to break things down. I've decided to break it down into these three different things. We could have combined move and animation into one. That probably would be okay. I'm just trying to show you here how we can have multiple methods inside a class. And maybe down the road, we realize, it'd be nice to add some functionality to our player. That might take the form of, let's just go and write one more method, right? We're going to have build and add some code to it if we need to. So this seems like a good starting point for our template. And the benefit, right, kind of going back to draw here, is now instead of just having a bunch of lines of code that essentially achieve the same result, okay, we're still drawing a player following our mouse. Now conceptually our program is very different. We have a player object that has its own variables inside of it, and that player object has things it can do. It has functions associated with it. So now our main program loop, which is the draw function, looks a lot more straightforward. We're saying move, right? And maybe in fact, let's do animate first, okay? Move, animate, and draw the player. So now we can read this almost as English, right? This becomes very easy to follow. And as a result, it's going to help us kind of scaffold the rest of our game if we only have to worry about our game objects and not necessarily the details that they contain. Okay, so this is a strategy to manage the complexity. Make it a little bit easier for ourselves to build more interesting things. Okay, so now that we've done the player class, we have a really good foundation for the zombie class. Okay, so we're gonna now take this idea and we're going to expand it, right, into a zombie class. So that we can now have two different game objects. We'll have a player following the mouse and we'll have a zombie moving by itself. And this is where we're going to end the video. Okay? So just like we did with the player, we're going to write a class for the zombie. And this particular class is going to be a great starting point as a kind of copy and paste to do that. But before we write the zombie class, let's think about loading the animation images. So in the player constructor here, we're referring to mPlayer frames, which is this array up here. This is the number of images we have in, this is the array that contains our player frames. Okay. So if we're going to create a zombie object, we're going to need also an image sequence, right? We're going to need an array to store all of our zombie images. So that means in preload, we're also going to have to do something similar. Okay? We're going to have to write a for loop that's going to load all the images right into the correct array and so forth. So this is a great opportunity for us to practice writing a function just to, even though we're only going to load two different animation sequences, let's package it up so that it's a little bit more convenient. Okay, and in fact, down the road, by the time this game is done, we're going to be loading, in fact, three different animation sequences. We also have the female player character here that we're going to want to load eventually. So this seems like a good opportunity to write a reusable function so that we can make our lives a little bit easier. Okay. So let's talk about writing that function. So this idea of loading an image sequence into an array, right? We're going to call that loadFrames, and we're going to package that as a reusable function in our program. Okay? So the concept here is that loadFrames is going to take some parameters, right? So maybe we're going to have a prefix, right? This is going to be the first part of our file name. So we're going to have a first parameter called the prefix. We need to know the number of frames in the sequence. And then we need to know the extension of the file name, okay? And maybe we'll set that as a default so that we're going to assume PNG, right? But if we want to maybe load JPEG instead, we'll be able to specify that, okay? So we're going to write this little load frame function that, given a file name, right, and the number of frames in a sequence, its job is going to basically be to load this frames array in a more generic way, as opposed to specifically, this particular code over here. So let's do something like that. We're going to create an array. Let's just call it frames. Okay, and this is going to become a temporary variable that's going to allow us to load the frames into that array. And then when we're done, we're going to return the loaded frames at the end of the function. Okay, so that our program can then capture those and save them wherever it's convenient for us. Okay. So the idea is going to be similar to this. Right? We're going to write a for loop that's going to repeat for whatever num frames is. Okay, so we're going to repeat here. And then we are going to we're going to create a file name. Okay, so we could put that directly into the code here, but let's put it into a variable so that we can also print it to the console to see that it works. Okay, so I'm going to declare a variable here called file, and the file we want to load, right? That's what we're doing up here. It's going to be a combination of three things. It's going to be the prefix plus I plus the extension. Okay, so this is making it a little bit clearer what's happening. Right? This is the same as up here. We're just now going to be using the parameters to the function. Okay? And the default extension will be .png. So that's going to take these 3 bits, glue them together, and put them into a string called file. And then we can do a log to see that this is working. Okay? Now, to test that, we need to call our function loadFrames. So let's replace this with loadFrames. Okay? We're going to say loadFrames mPlayer, right? And we said mPlayer had 9 frames, so we're just going to put in the number 9 here. And that's it. We're going to use PNG as our default extension, so we don't need to add the third parameter. So if we run loadFrames, this is going to happen. Let's comment out. Okay, so we can see here we're getting some issues down the road because we're save the frames into the mPlayer frames. We'll get there in a second, but we can see in the console, this is printing out our image sequence. Okay, and I can notice there's a mistake here. I forgot I forgot the dash. Okay, so I can already tell. This is also why it's helpful to print things to the console often, because otherwise you might miss things like that. So I forgot the dash. Perfect. Let's run it again. There we go. This is the correct sequence of file names. So that looks pretty good. So now that we've made the file name, of course, we need to load the frame. So we're going to say, go into this temporary array frames here at index I, and then we're going to say load image file. Okay. So we're going to load image file, put it into frames, and then we're going to return frames at the end, which means as we call load frames, we can now say mPlayer frames equal to load frames. Okay. Let's try that. Now our code works again, and we can see which files we're loading in the console. Okay. So the point of doing this, well, first point is to it's a great excuse to recap writing functions, so that's perfect. But it's also convenient for our game because now when it comes time to loading these zombie frames, right, we can just reuse this command we just wrote, and we just need to pass in a different file name and a different number of frames. Okay? So let's say zombie frames is going to be equal to load frames. So it took a little bit of work to write this function, but now we can reuse it. That's the power of functions. And my files for the zombie are called zombie, just lowercase. Okay. And this particular sequence has 6 images in it, right? It goes from 0 to 5. So we're going to put 6. Great. So now I have I'm reusing my load frames function twice. And if you can imagine, if we had a more complex games with all kinds of different image sequences, we could reuse that command we made up every time we want to load an image sequence into an array. So that's a really great use case for writing a command, writing a custom function that returns a value at the end, right? That isn't doing math necessarily. It's not doing a calculation. It's doing some work for us, right? It's going to create this array, and then when it's finished, it's going to return it. So this is a great use case for functions that have return values. All right. So with that out of the way, we can turn our attention back to developing our zombie template. Now that we have our zombie frames confidently loaded into this zombie frames array, right? So I have no reason to expect this is not working. We are going to turn our attention to writing a zombie class. So because we said our player class is going to have a lot of similar attributes to the zombie, let's just copy and paste it as a starting point, okay? Just to cut on the typing a little bit. So I'm just going to copy and paste here, and I'm going to rename this to zombie because I cannot have 2 classes that have the same name. So I have a player class now, and I have a zombie class, which kind of is identical. Okay. The only thing is now we're going to make some changes to our zombie class to make it unique, and we're going to kind of go through it and see how the zombie might behave differently. Okay. So let's start with the constructor. Well, a zombie is still going to have a position, right? So that's fine. It's going to have its own animation sequence, and here instead of mPlayer frame, we're going to refer to zombie frames because we're defining a zombie object. And then it's going to have its own animation, and we also want the zombie to flip itself around to face the correct direction. So we're going to keep all of that. Obviously, the move method for the zombie is going to be quite different from the player. So the player moves by following the mouse. The zombies in our game just move by themselves. So the zombie is going to move by itself. So in order to do this, we're going to borrow the bouncing ball idea we developed in earlier lessons, and we're going to apply this to the zombie. Okay? So what that means is we're missing a few variables up here for our zombie object. So not only does our zombie need position, we need a little bit more detail for the zombie. We need to know which direction is it moving. In other words, what is its speed? Okay. So let's give our zombies random speeds. Okay. So just like what we did moving circles, it's the same idea, except now we're going to have moving zombies. And while we're at it, it would also be nice if zombies don't always start in the top left corner. Maybe their starting position should be random. Okay. So we're diverging a little bit from the player template, and that's fine because these are not going to be the same object. So now that we have X and Y and speed X, speed Y, we can replace the motion code here with something different. We're going to say the zombie moves by adding its speed to its position. All right, so I won't explain that again because we've done this many times. And then we're going to say if the position, right, reaches the boundaries of the window, we're just going to get the zombie to turn around by reversing its speed. And we're going to do the same thing on the y-axis, except we're going to compare with height, and this we're going to reverse speed y. Okay. So let's leave that here for now, and then we can leave that comment. The drawing code doesn't need to change, right? The drawing code is identical. To draw the zombie, we're going to translate to the origin to that object's position, scale according to flip, draw an image, right? And the animation also doesn't need to change. So both of these are the same. So we're going to just, our work's already done. Awesome. So let's test this out. We're going to create a zombie variable. Let's call it zombie over here. And so first we declare a zombie variable. Then in setup, we're going to say zombie equals new zombie. And we can do that because we created a zombie class, right? This in turn is going to run the constructor, which will perform this code. And now we're going to have a newly minted zombie object that we are free to use in draw in our program. We could say zombie.draw. And now we're going to have a zombie appear. Okay, got a random position. We could say zombie.move. That's going to cause the zombie to start moving and do its bouncing thing, right? And if we wanted to animate, we're going to call its animate code. Zombie.animate. Got a little moving zombie. The only thing missing that we forgot, we didn't do, is we are never updating the zombie's flip variable, which means it's never getting scaled whenever it's moving to the left or to the right. Okay? So how do we know which way the zombie is moving? Well, this is a lot easier than for the player. In fact, we have that information already in front of us. If the zombie's speed x variable is positive, then it's moving to the right. If its speed x variable is negative, then it's moving to the left. Okay, so we can simply look at that in here and say, if speed x is negative, then, positive, let's start with positive, then we should be face right. And on the other hand, if speed x is less than 0, face left. Okay, so we already have the information inside speed x. So now this zombie eventually will turn around. Once it reaches the edge, right, based on its speed x value, the flip variable will update. There we go. So now it's facing the right way and it's chasing us. No. Okay. All right. So obviously we don't have collisions yet. We don't have anything else. But what we do have, let's take a little recap, is we've now kind of created some structure in this program such that we have two different objects, right? It's in our simplified game world, we have a player object and we have a zombie object. This is a great place to be in, right? We have our two variables up here. The other thing we did is we wrote this function that sort of took the idea of loading an image sequence and made it reusable, right? So that we don't have to repeat ourselves every time we want to load a new image sequence. We can just use the command we created. And it does so by taking a few parameters and then using those parameters to kind of generically load any image sequence, right? If we give it the correct name and the number of frames and the extension optionally, the logic is always the same, right? Create an array, go through using a for loop, load all your images into the array, and then when you're done, give it back, right? Here's your loaded frames array. And then we can catch that and put it into different variables up here that we're going to use later on in our code. And then in setup, we create a player object, a zombie object that gives us our two game objects. And inside of those, all of our variables live inside these objects now. So the position and all the details of our player all lives inside the player object, and all the details relating to our zombie all lives inside the zombie object. This is great because things are now packaged, right? Things are kind of in their own compartments, and that's going to allow us to more easily build the rest of our game logic in the following video. In the draw command, we simply tell our player to run through everything you can do, move, animate, and draw. And then the zombie also should do it in maybe in different order. We should also do move, animate, and draw. Doesn't really matter for this game, but so we're telling, do everything, and that gives us this resulting program. And all the juiciness, all the meat around the bone is all packaged into these two templates. So we have our player template, and this is where we define the actual code that does things in the program. Okay? So we have to do this once, but then once we've created it, and we were able to leverage this to make the zombie template very quickly, right? So that went very fast because we reused some similar ideas. And then once we kind of made it work, we are going to be able to turn our attention to building the rest of the code using these two objects, and then revisiting the template as needed if we need to add more detail as time goes on. Okay. All right. So we're going to leave it at that for this video. In the next video, we're going to start to think about our core game mechanics, which is collision detection, right? So we need to know when this zombie is eating the player. So we're going to focus on that in the next video. I will see you there.